The 1961 Ferrari 250 GT, California. Less than 100 when made. My father spent 3 years restoring this car. It is his love, it is his passion.
It is his fault he didn't lock the garage.
Ferris, what are you talking about? Ferris, my father loves this car more than life itself.
A man with priorities so far out of whack doesn't deserve such a fine automobile. There's nothing else we can do.
He knows the mileage, Ferris.
He doesn't trust you?
Never has, never will.
Look, this is real simple. Whatever miles we put on, we'll take off.
How?
We'll drive home backwards.
No.
No! Ferris, forget it. You're just gonna have to think of something else. I'm putting my foot down. How about we run a nice Cadillac? My treat!
How many miles did you say this thing had on it when we left?
126 and halfway between 3 and 4/10. Why? How many miles are on it now?
Here's where Cameron goes berserk.
Hey, Ferris! The miles aren't coming off. The miles aren't coming off, going in reverse.
Huh. Well, I thought that might be a problem. Just have to crack open the odometer, roll it back by hand.
No, forget it.
I always think of that movie when I start to talk about absolute value. It's a movie that's, of course, from the 80s. It's way before your guys' time. But I always think of it because they talk about driving the car backwards, or what they did was they put it in reverse on a lift to try to take the miles off of it. And, of course, all it did was add more miles to it. Because absolute value, distance, can't be negative. Absolute value, if you remember way back from middle school, is the distance from 0 on the number line. So if I'm talking about distance, it always has to be positive. So if I'm talking about the absolute value of 3, for example, how far is 3 from 0 on the number line? It's 3 units. So the absolute value of 3 is 3, but the absolute value of negative 3 is also positive 3, because it is also 3 units from 0 on the number line, and that distance of 3 units can never be negative. So we always talk about absolute value in a positive, with a positive number. Today we're going to be looking at absolute value graphs and absolute value equations. We're going to combine these. The graphs, we're going to look at a few things about the equation of a graph and talk about what we can figure out about the graph from the equation, and then we're going to solve some absolute value equations. This video, of course, is on Edpuzzle today because I'm not at school, so it is a required video for all of my classes. There is an optional video after this one, so you've got three different videos today. 2 of them are required, and 1 of them is optional. The one that's optional is the classwork that goes with this particular video. You can watch it if you want, or you can do the classwork on your own. That is your choice. I've separated them into 3 videos instead of doing an hour-and-a-half long video. So again, we are looking at absolute value graphs. And if you remember my honor students on your quiz that you took on Friday, there was an absolute value graph as your bonus. And a lot of you were able to get that correct. You were you saw the poster on the wall, some of you, and were able to decipher the poster. So an absolute value graph, the parent function is actually just this simple function right here. So I'm just going to draw a little arrow and write parent function. So this is the parent function, very simple. F of x or y equals the absolute value of x. So if I were to graph the parent function here, I could do a little XY table if I wanted to. So let's do -2, -1, 0, 1, 2, which are really common x values that we choose. If we were to choose these x values and then plug them into this parent function, the absolute value of negative 2 is 2, because negative 2 is 2 units from 0. So absolute value of negative 2 is 2, absolute value of negative 1 is 1, 0. The absolute value of 1 is not negative 1. Don't make that mistake. It's always a positive number. And for that reason, if we go to negative 2 and then 2 here, and then negative 1, 1, 0, 1, 1, 2, 2, that's the reason that they always look like a V, because you always have the same values the values are mirrored. Just like in a parabola, they're mirrored, because in a parabola you got x squared, and anything squared is going to be a positive number. So absolute value graphs are always shaped like a V. And this is the parent function. That's what it looks like. So if you look at this line over here, you see that the slope is 1, up 1 over 1, up 1 over 1, and so on. Slope over here is negative 1. We're going to talk about that in a minute. So this is the more expanded version of the parent function. If you have a 1 here, a 0 here, and a 1 here, that's the parent function. You looked at sliders the other day on Desmos, and if you put the A at a 1, the H at a 0, and the K at, the H at a 0 and the K at a 0, that would give you that parent function. And then you slide those around and see what they do to the graph. So let's just talk about that a minute. The K is probably the easiest part. If K is positive, I'm just going to make a couple little notes and you can write these too. A positive K means that it moves in an upward direction. The vertex, the original vertex, moves in an upward direction. A negative K means that it moves in a downward direction. Now H is the tricky part. Because this says X minus H, that's what makes that a little bit tricky. But if H is positive, and I'm going to just write this, and then I'm going to talk to you a minute about the minus. If H is positive, that is a right movement. That means that that vertex moved to the right. If H is negative, that does mean that it moves in a left direction. I want you to notice, though, that it's X minus H. So X minus that negative number is going to give you X plus H. So, or X plus the number. I'll show you an example. So, a couple other things I want to note is that if A is positive, that means the graph opens up just like a parabola would do. These are really similar to parabola. And it has a minimum. I do want you to write all this. If A is negative, that means it opens down. And it has a maximum. Now, if A is between negative 1 and positive 1, that means it's a fraction. In other words, if it's a positive fraction or a negative fraction that's less than 1, it's not a mixed number. So if it's a fraction where the numerator is less than the denominator, basically, then that graph is going to be wider than the parent function. In other words, it's going to have that vertical compression. Remember the marshmallow that we squeeze it from the top and bottom, and it has the vertical compression, but that also means it has horizontal dilation or horizontal stretch. So that's what that means. If you see a fraction as the A, it's going to be wider than the parent function. If A is less than 1, in other words, if it's a negative integer, or A is greater than 1, that means it's going to be narrower. It's going to have that vertical stretch. So it's going to be narrower than the parent function. And also understand that A is the slope of the AB function. And what you can actually do is just look at the right side. So that means look at the right side of the graph. And whatever the right side is, if it's going down this way, it's a negative slope. If it's going up this way, it's a positive slope, or it's positive A. So this is positive A, this is negative A. And so that is where x is positive is the right side of the graph. And then one other thing that I wanted to make sure that you understand is that the vertex can always be found by looking at h and k. The vertex is h, comma, k. So this is the x value of the vertex. This is the y value of the vertex. And to find h, set that part, x minus h equal to 0, and then solve for x, and that will give you the x value. So let's look at a couple of examples. Let's look at 1, 2, and 3. It says use the equations to answer the following questions. So the easiest way for me to tell you to find the vertex is this. Set whatever's in here equal to 0. So x plus 1 equals 0, x equals negative 1. That means h was negative 1. But all you need to do is set it to 0. The vertex is going to be negative 1, and then whatever is on the outside here is the k value. Well, there isn't anything, so the k value is 0. No up or down movement. So the vertex is negative 1, 0. A is negative. Negative A tells me that this thing opens down. A is a whole, not a whole number, but an integer, so it's not a fraction here. So that means it is going to be the same as the parent function. The slope is going to be 1. If there was a 2 or 3 here, it would be narrower. If there was a 1/2 here, it would be wider. So just look for either a 1, if it's a 1 or a negative 1, same as the parent function. If it's anything less than that or greater than that, if it's like a 2, 3, negative 2, 3, then it's going to be narrower. If it's a fraction, whether it's positive or negative, it's going to be wider. All right, let's look at the next one. Well, this, if I set what's in here equal to 0, x equals 0. So that means the vertex is going to be 0, and then this number right here, which is 5. It opens down because it's a negative a. It's a negative 1a, so that means, again, it's going to be the same as the parent function. The next one, number 3, p plus 3 equals 0. If you haven't figured it out by now, it's just the opposite of this number is the x value, so negative 3. I put negative 1 for some reason, negative 3, and negative 6, vertex. It opens up. The a is positive. Now you see here it has a 3/4. If you have a fraction, now if this said 4/3, that's greater than 1. But if the numerator is less than the denominator, then it's a fraction that's less than 1, and it's going to be wider than the parent function. Okay, moving on down this page. Number 4 says graph the absolute value function. So let's look at this. X plus 3 equals 0. X equals negative 3. The vertex is at negative 3, 5. So what we can do is we can go ahead and graph the vertex. Vertex negative 3, 5 is right there. So there's the vertex. That was the movement. The A, let's see, A is negative. Slope, it opens down. So the slope is going to be negative 1. If I know that, all I have to do is just count. Down 1, right 1. Down 1, right 1. Same thing over here. Just mirror those points and then join them. My translations, we'll go ahead and do the translations. Of course, this is left 3, up 5, and it reflects over the x-axis. Now, I want you to think about something. We talked about reflecting over the y-axis, but I want you to think about this. If this thing reflected over the y-axis, would it look any different? I mean, like, let's say the parent function reflected over the y-axis. Is it going to look any different if it flips this way? No, it's the same. So we don't really talk about reflecting over the y-axis with an absolute value function. We just talk about the movement and then reflects over the x-axis if it opens down. So that's all we need for that one. Number 5, we have in the absolute value symbol, we have x plus 1, x equals -1. So the vertex is -1 and -1. The A is positive, but the slope here is 2. So it's gonna open up. Let's go ahead and do the vertex. -1, -1's here. The slope though is 2. So that means I go up 2 and to the right 1. And let's mirror those points. Let's see. So this one's skinnier because it's got that 2. It's skinnier than the parent function. The translations opens up. There's no reflection. If you didn't write that, I wouldn't count anything wrong. It's left 1, down 1. Okay. Number 6. What this one says is use the graph to write the vertex and the absolute value function. So let's just look at the vertex. The vertex is 2, 3. 2, 3. So, and it opens down. So A is going to be negative. Let's look at what the slope is. If I go from here, I want to go from here to this point right here. Because here to this point, I don't know what that is. So I went down 2 and to the right 1. Now think about that. Down 2 to the right 1. That's a -2. And that is a positive direction. So that is a slope of -2. So then I can write the equation. Y equals, that's going to be a -2. And my absolute value symbol, be sure you can tell that that's an absolute value symbol. It is x minus 2 plus 3. It did not ask us to talk about the translations in particular, so this is the answer that we're looking for. These are just notes. Number 7, same thing. The vertex is at -1, positive 2. Slope is 1, positive, so it's positive 1. Y equals absolute value symbol, x plus 1 plus 2. So that's all I'm going to do with the graphs for now. I think it's on Wednesday. We're going to come back to the graphs and we're going to look at other key features of the graphs and do an activity with that. But for now, we're going to move on to absolute value equations. I want you to look at this little dot bubble over here. It says, can this happen? The absolute value of x is -3. No, because it's a distance. Distance cannot be negative, so the answer is a big fat no, this cannot happen. So I want you to remember that as we go through and check our answers. These are the steps for the absolute value equation. So if you see an equation with an absolute value symbol in it, you can solve it, and that's what we're going to do next. We're going to isolate the absolute value, and then we're going to take it out of the absolute value bars and set it equal to the original version. Then we're going to set it equal to the negative version. Because if you have the absolute value of some number equals 3. Let's just go with 3. We've been using 3. Well, there is not just one value that could go in there. There are 2. You could say the absolute value of 3 equals 3, or the absolute value of -3 also equals 3. So if I have some number equals, absolute value of some number equals 3, it could be a positive 3, so x could be a positive 3, or x could be a -3. So this is why it says, without the absolute value bar, set it equal to the negative version. So let me show you what that looks like. And I've put the steps in each one of these down at the bottom so we can keep looking at them. So this first equation, I need to make sure that what is in these absolute value bars is isolated. So it's by itself. There's nothing over here on this side. There's nothing on this side. Once I do that, then I can do my 2 different sides. So what we're going to do is we're going to remove the absolute value bars, and we are going to set this up equal to positive 23. And then we're going to do a separate equation over here, same thing on the left side. It's always the same on the left side, equals And then we're going to set that up equal to the negative version, the negative 23. Because what's in those bars could be positive 23 or it could be negative 23, and it would still equal 23 if it's in the absolute value bars. So let's just solve both of these. I'm going to subtract 3 here. 4x equals 20. Divide by 4, x equals 5. So x could equal 5. If I plug it in up here, 4 times 5 is 20 plus 3. That's the absolute value of 23. So you can check that one really easily. Let's do this one. Subtract 3 on each side. 4x equals, that's going to be a negative 26. So divide by 4. X equals negative 26 over 4, which is negative 13 halves. A little bit more difficult to plug in up here, but if you check it, it will come out to be the correct number. What you'll get up here though, let's just do it real quick. 3 plus 4 over 1 times negative 13 halves. Let's see if that equals positive 23. Keep it in the absolute value symbol while you're checking it. 3 plus, that's going to be negative 26. Absolute value of negative 23 does in fact equal positive 23, so that checks, and I know that this is a possible solution and this is a possible solution. You do want to check them, and I'll show you why in just a second. Okay, so this one, I'm going to highlight this absolute value again. So what I want is I want this thing right here by itself. What I'll tell my students sometimes is treat this like it's a variable. So like this yellow thing right here has to be by itself. So pretend that's like an N or something and get it by itself. That means I have to add 5 on both sides before I take this out of the absolute value symbol. I got to keep it in these bars until I get it by itself. So then I have absolute value of x plus 8 equals 7. So again, still want to make sure that that is by itself. It is. So now what I do is this second step, without the absolute value bar, set it equal to the original version. That is 7. X plus 8 equals 7. And then over here, x plus 8 equals negative 7, because what's in there could be a positive 7 or a negative 7. Subtract 8 here, x equals negative 1. So that's a possible solution. Subtract 8 here, x equals negative 15. So let's look. Negative 1 plus 8, that's positive 7. Absolute value of positive 7 is 7. Negative 15 plus 8, that's negative 7. Absolute value of negative 7 is 7. So this is a solution, and this is a solution. So either one of those could be in there. All right, next one, number 3. I'm going to highlight it again. This part right here, I need to get by itself. So if this was, let me just show you. If this was negative 5n plus 2 equals negative 73, the n part is this highlighted part right here. So that is the same as this. I'm trying to get n by itself when I solve this. I'm trying to get the highlighted part, the yellow, by itself. So negative 5 times yellow plus 2 equals negative 73. I'm going to subtract 2 first. Still trying to get this by itself. It's not by itself yet. It is still tacked on to that negative 5. So now I'm going to divide both sides by negative 5, which I can do. Now it's by itself, and I'm not going to highlight these every time. I just want to show you that this is how you get it by itself first. You've got to do that part first. Number 1, isolate the absolute value. Now I can take it out of the bars. 5x minus 5 equals 15. Remember over here, 5x minus 5 equals the negative version of that, negative 15. Then solve. So I'm going to add 5. 5x equals 20, so x equals 4. And then I'm going to add 5 here. 5x equals negative 10. So x could equal negative 2. I'm not going to go through the check step. You need to. There is one that I'm going to show you with the check step in a minute. But this one, I'm going to just tell you, both of these do check. So these are possible solutions for this one. Number 4. it's already isolated, so I can go ahead and take it out of the absolute value symbol and set it up equal to positive and negative. So let's see, I'm going to subtract an x here. Negative 2 equals x. 2x minus x is just x. So this is a possible solution. And then I'm going to subtract an x here, and that would be negative 2 equals negative 3x. 3 halves, sorry. No. I got ahead of myself. Negative 3x. Negative 3x, and then divide by negative 3. 2/3 equals x. Okay, now I want to show you. Sometimes when you go up here to check, let's put this in for x. You gotta plug it in 2 places. So I'm gonna say if you see an x on either side, be sure to check that solution to see that it is a solution. So let's see. Absolute value of negative 2 minus 2 equals 2 times negative 2. I can never have this right here. I can never have a negative number over here. Absolute value equals a negative number. So 4 does not equal negative 4. So this is not a solution. That's not a possible solution. If you go up here and you check the 2/3, I'm just going to tell you that it will check. So 2/3 is a possible solution. It's the only solution that would work. Okay, number 5. I'm going to encourage you just to pause the video and try this one. This one's already isolated, so you just go ahead and set it up both ways and then solve it and see what you get, and then come back. Okay, so this is what you should have gotten. You should have gotten x equals 7 or x equals negative 1. I'm not going to go through the check step on these again. I'm just going to tell you that they would check. So these are your 2 solutions. Number 6, same thing. I would encourage you to pause the video and then come back and see if you got it right. Okay, so this side right here is where I isolated the absolute value. I subtracted 5 from both sides, got negative 6, and then I divided by negative 1 on both sides because I have this negative here. And then over here is where I separated them into 2 equations, and I ended up with x equals 6 or x equals a negative 18. So I'm going to work through this last equation with you, and this will be the end of this particular video. And then you'll move on to the next one, or you'll work on the classwork by yourself. The classwork is on the front table. So let's see here. We need to isolate this part right here, this part that's in the absolute value symbol. So the first thing I'm going to do is subtract 4 from both sides. And I get 9x minus 9. Then I still want to isolate this part, and I am going to highlight this so you can see. I still need to get this by itself. Well, it's got 3 times it, so I can divide by 3 on both sides. Now, I want to show you something. When you divide by 3 over here, you're not going to have this big fraction. I have absolute value of 6x minus 9 on the left. And then on the right, I can pull a 3 out of this part right here. This equals 3 times 3x minus 3 divided by 3. And these cancel. So then I have 3x minus 3 on the right side. Now I'm going to take it out of the absolute value. I think you have a little more room down the bottom to work this one, which is good. 6x minus 9 equals 3x minus 3. Be careful with this, with the other side. 6x minus 9 equals the negative version of 3x minus 3. You need to put that in parentheses and then distribute that negative in. Let's go ahead and rewrite this one. So 6x minus 9 equals negative 3x plus 3. All right, so over here I'm going to add 9 over here, so that gets rid of that, and then I'm going to subtract 3x on the left. So that's 3x equals 6. Divide by 3x equals 2. So that's one of my solutions. Oh, and then on the right side, I'm adding 9. And I'm adding 3x. That is 9x equals 12. Divide by 9. X equals 12 ninths. And then simplify that. Let's divide by 3. 4/3. So that was a solution. And they both will check out if you substitute them in for X. So now at this point, you'll need to get your classwork from the front table, and you have the option of working on that by yourself or watching the second video, the optional video for classwork 6, and working through those with me. Once you get finished with that, you do have another required video that's on absolute value inequality.